Okay, so we are going to be taking a problem to determine the shape factor of a circular section. So the question says, show that the plastic moment and shape factor of a beam of solid circular cross section having a radius r and yield stress sigma y are 1.33 sigma y r cube and v is equal to 1.69. Okay, so from the question we are asked to show that for a circular section, okay, we show for a circular section that our plastic moment MP is equal to what? 1.33 sigma y arrow cube, where our sigma y is our yield stress, arrow is the radius of the circle, and we are also asked to show that the shape factor is equal to 1.69. Okay, now first, how do we get our plastic moment? So our plastic moment MP is simply equal to what? Our plastic sectional modulus. Okay, so it's simply equal to our yield stress sigma y times our plastic section modulus. So with this expression, we can determine our what? Plastic moment. Now the second part says we should determine our shape factor. Now shape factor shape factor is simply equal to our plastic moment all over our elastic moment, where our elastic moment My is equal to our I all over the Y, where Y is the distance from the boundary of the circle to the center. So to determine our shape factor, we simply need to have the value of our what? Plastic moment and our elastic moment. And we can get our plastic moment from this and our elastic moment from this. Okay, so let's get our plastic moment. We know our yield stress, which is sigma y. So our first task will be to get our plastic moment. Now, when we want to determine our plastic moment, we simply consider our point of neutral axis. So for that circle, okay, so we have, this is the circle. So we split the circle into two. Okay. All right. So from this point, okay, this point to this point is our point of neutral axis. Okay. Now, our plastic section modulus ZP is giving us area of the section all over 2 into y1 plus y2. Okay, where this is what? Y1 for the upper part, and this is what? Y2. Because it is a cycle, our y1 is equal to our y2, and our y1, okay, let me get that down here. So from that, our y1 is equal to y2. Okay, so our y1 is equal to our y2, and this is equal to 4 arrow all over 3 pi. All right. How do we get our area? Now, we need to express our plastic modulus in terms of what? Arrow. We know that area of a circle is equal to what? Is equal to what? Pi d what? Also, it is equal to what? All right. So because we are asked to express our plastic moment in terms of arrow, we will make use of what? This. All right. So we have our A to be equal to what? Pi arrow square. All right. So our plastic section modulus ZP is simply equal to what? A all over 2, and our A is what? Pi arrow square all over 2 into y1, which is what? 4 arrow all over what? 3 pi plus what? 4 arrow all over 3 pi. Okay. So our plastic section modulus ZP is equal to pi arrow square all over 2. Now, this is 2 of this. Okay. So this is multiplied by what? 2 of what? 4 arrow all over 3 pi. So at this point, this takes away this. This takes away this. Okay? So we have our plastic section modulus ZP to be equal to what? We are left with what? Arrow square, 4 arrow, and what? 3. So arrow square times 4 arrow is equal to what? 4 arrow cube all over what? 3. 4 divided by 3 is what? 4 divided by 3, 1.33 arrow what? Cube. Alright? So we have gotten this is our what? Plastic section modulus. 1.33 arrow what? Cube. Now they said we should express our plastic moment. And what is our plastic moment? Our what? Our plastic moment is simply what? Our yield stress times our what? Plastic section modulus. Okay? So our plastic moment, MP, is equal to what? Sigma y times ZP. And ZP is equal to this. Hence, our plastic moment is equal to what? Sigma y, or writing the numbers first, 1.33 arrow cube times what? Sigma y. Hence, we have been able to prove that for this circular section, our plastic moment is what? 1.33 sigma y arrow cube. So, since they gave us in that expression, we can simply write it in that manner. So 1.33 sigma y arrow cube. So we have answered the first part of the problem. The second part says we should find what? The shape factor. And our shape factor is given as what? Our plastic moment all over what? Elastic moment. Okay. So after getting our plastic moment, the next thing we need to determine is to determine our elastic section modulus, knowing that our elastic moment My is equal to our yield stress times elastic section modulus. Okay, so our elastic section modulus Zy is equal to I all over y. Now y is simply the distance from our centroid, okay, for a circular section, from our centroid to the boundary of the circle, in which is equal to our radius. Hence, our y is equal to arrow. Our I, moment of inertia, for a circular section is given as pi d4 all over 64. But because our expression is with respect to arrow, we are going to take it in the form of arrow, which is given as pi arrow 4 all over 4. Okay, so substituting this into this expression, we have I, which is what? Pi arrow 4 all over 4, okay, divided by our y. So it's divided by our y, which is arrow all over 1, taking inverse 1 over arrow. So at this point, this arrow cancels out 1 part of this arrow. So our plastic section modulus Zy is equal to pi arrow cube all over 4. So it's pi, 1 part has been taken out, pi arrow cube all over 4. So pi, which is 3.142 approximately, divided by 4 is equal to 0.79 arrow cube. So we want to determine our shape factor. So our elastic moment, My, is equal to what? Our yield stress times our what? elastic section modulus. Okay, so our my is equal to sigma y times 0.79 rho cube. So if we arrange that, equal to 0.79 sigma y rho cube. So having gotten the value for our elastic moment and our plastic moment, we simply substitute in the value to get our shape factor. Hence, our shape factor is simply equal to our plastic moment, which is equal to what? 1.33 sigma y rho cube all over what? 0.79 sigma y rho cube. This cancels this cancels this. Hence, 1.33 divided by 0.79 is equal to what? This is equal to 1.68. 1.68. Okay. So we have been able to prove from the given problem. So 1.68, 1.69 is approximately the same. We have been able to prove from the given problem that indeed for a circular section, our shape factor is what? 1.68.